Okay, so how is everyone today?
Great.
Great? Good.
Friday.
Friday. All right. So last time we were talking about polynomials. Still have a couple things to say. So we had mentioned a few vocabulary words. One of them was term. So term, those are when you're writing down math formulas and things like that. Those are the things that are separated by pluses and minuses. And then factors are the things that are separated by multiplies and divides. Those are called factors. All right, good. So in the specific case, so these are some special names that you need to know. Is that all right? So a polynomial term. Remember, terms are things separated by pluses and minuses, but a polynomial term is special because it has to be a number multiplied by a variable. Very often that is x raised to a natural exponent, or it could be just a constant by itself. Such a thing is called a polynomial term. So some kinds of polynomials are held to be special. So polynomials with exactly two terms, such things are called binomials. So when it's something like a plus b. So like a plus b. Okay, and an example would be, something like, say, like 3x squared minus 4. Okay, that's a binomial because there's two terms there. All right, if there's three terms, that one also has a special name. 3 has an h in it. So that's called a trinomial. So things that are like a plus b plus c. And you can imagine an example. Maybe like 13 times x to the 14 minus 5x plus 7. So there's a trinomial. Okay. So now those prefixes bi and tri, I think they're like like Greek or something. I can't remember. But they mean respectively 2 and 3. So there's other Greek prefixes like quad. So like I guess in principle you could say quadrinomial, but people don't really say that. Like another one is like dodecanomial. What would that be? That'd be 12, right? Because y'all remember dodecahedron from elementary school, 12-sided figure. All right. So then concerning this thing right here, there's three terms: 1, 2, 3. So 1, 2, 3. And then concerning this particular term, how many factors does it have? Just that term that I'm pointing at. That's 2 factors. And then, is this a polynomial term? It is. There's a seat up here, right here at the front. So, is it a polynomial term? Yes, in the end, because polynomial terms have to be a real number multiplied by a variable, so x in this case, raised to a natural exponent. So is 14 natural? It is natural. So what would be an example of a non-natural? A negative one? So like if it said x to negative 14, then this would not be a polynomial term. Okay, good. Any questions about this? So very often binomials and trinomials come up, so now we can refer to them with that name. So last time we did an example of multiplying out the product of two polynomials, and it was like, we did it really tediously, like showing every distribution. Okay, so then you're going to have an exercise where you have to do it that way. And but you won't have to do it that way every time, right? Because part of the way this course works is that we have you do these things, but you kind of got to do it the long, complicated way, but just once, right? And then you can do it the easy, shorter way in the future. So one of those easy, shorter ways is this. So now we're gonna come up with a nice formula for the product of binomials. Product of binomials, and then I'll say AKA for also known as, and then I'll leave a blank here because you probably already know this name. If your experience so far is that a lot of this has been reviewed for you, you know what I'm about to do, but by a different name. So specifically, that's a binomial because it's of the form a plus b. And this one is a binomial because it's of the form c plus d. And what we're doing is we're computing product. So the product of binomials. All right. So from a high-level point of view, when something's in parentheses, you can kind of just cover it up and obscure it. So from a high-level point of view, what I want you to see is we're considering an expression with how many factors? 2 factors, and then concerning each factor, this particular factor has terms. How many terms? 2 terms, right? A and B, and this one has 2 terms, C and D. All right. So the way we're going to do this is we're just going to distribute, just like we did on the last example of last time. So I'll take this a plus b here, and I'll say, okay, you get a a plus b, and you get an a plus b, which is why this is called distribution, because it's like handing out, distributing. Okay, so then doing that, you could write that this is a plus b, and then multiplied by c there, and then plus a plus b multiplied by d. All right. Now, to continue, now we can perform even more distributions. So this c now can distribute to the left. So you get a c, and you get a c. And now the d can distribute to the left. You get a d, and you get a d. All right, so doing that, this is a multiply c plus b multiply c plus a multiply d plus b multiply d. Okay, so now in the expression as we have it written, how many terms? 4 terms. And then concerning each term, for example, that term right there, how many factors? 2. So this is 4 terms, all of which have 2 factors. Okay, so now these are all added, and addition commutes, which is to say it's permitted to make them appear in a different order, like 3 plus 5 is 5 plus 3. So for reasons that aren't entirely clear yet, I'm going to leave that one in that place. I'm going to leave this one in that place. But as for the middle 2, I'm going to switch their positions. Okay. So, to be clear, what I did is I took this one and moved it over there, and this one there. And that's permitted because that's because addition commutes. So what we're saying is that this product of binomials, a plus b, multiplied, Gesundheit, multiplied by C plus D is that. All right. So now what would be really nice is if we had some kind of cute and easy way to remember all this. So now, concerning just this binomial here. So I'm covering the other one up. So concerning just that one, it's got those two terms, A is one of the terms, and B is one of the terms. Concerning those two, which one would you say is the first one? In there. Yeah, A is the first one. Yeah. How about in this factor that has two terms, the terms C and D? Which one is first? Okay, so you're telling me that for this one A is first and for that one C is first? Ah, but look, of these four terms, doesn't one of them have doesn't have A and C? Ah, that's the one that has both of the firsts. So I'm going to label that one as F for first. And then again, concerning just this factor and its two terms A and B, of the two terms A and B, which one would you say is last? B. And for that one? D. So B and D are the ones that are last? Is there a factor on the right-hand side that has B and D? Ah, right there. So if it's not, surely for most of you the cat is already out of the bag, right? You already see the punchline, I hope. So now, concerning these like all together, like just as a group, A, B, C, and D, which terms would you consider like to be the ones that are on the outside? Yeah, probably A and D, right? Yeah, because A is furthest to the left and D furthest to the right. So we'll call those the outside ones. And look, there's a term that has its factors are A and D. And then what's the opposite of outside? Inside, right? So concerning these four, which ones would you consider to be the inside ones? The B and C ones, right? This thing you probably knew before you got here, called FOIL. Okay, which stands for first, outside, inside, last. Great. So what I want you to understand from this is that what FOIL actually is it is three distributions, 1, 2, 3, followed by a commutation. That's what FOIL is. And there's various little formulas like that, like FOIL, that can make your life a lot easier. Rather than doing this and that, you can just sort of like omit that and just jump to that part. So what I'm saying is that there's going to be a question posted this afternoon that says do a product like this, but do it the long and tedious way, showing every distribution. Just that one, and then from there, please use things like FOIL after that one. Okay. So an example. So something like 13x plus 14. Multiplied by 5x squared plus 4, something like that. So two binomials, and we want to consider their product. All right. So since this is the first time I'm using FOIL, I'm going to, again, do it kind of in slow-mo. So the F terms are those. So this would be 13x multiplied by 5x squared. So that's the F. Okay, and then O, the ones on the outside. So that'd be plus 13x multiplied by 4. The I terms, so that'd be 14 and 5x squared. And then the L terms, 14 and 4. Okay, so F, O, I, and L, right? So then now, normally, once you're accustomed to this, you usually don't write it quite this way. What you usually do is you just kind of look at those and then you perform a multiplication in your head, because once you get used to it, it's more or less straightforward. So multiplication commutes, and is associative, that means that you can drop those parentheses and then move all the coefficients to the front so that 5 and 13 are together. What's the product of 5 and 13? 65. Be 65, and then that's x, and that is xx. So commuted all together, that's xxx. So what's that? X cubed. Okay. Again, 13 and 4 would be 40 and 12, right? So that'd be 52 x's. Here, this would be 50 and 20, so that'd be 70 x squareds. And then these together, that'd be what? 40 and 16 would be 56. Okay, and then now for all of these, you need to collect like terms and what have you. So, is there anything to collect? No? Why not? Right. Good. So remember that where kind, collecting like terms, likeness means same degree. So like the degree of this term is what? Is degree 3. Are there any other terms of degree 3? There aren't any others, so no others are like it. Similarly, this is degree 1, and there are no others. This one is degree 2, there are no others. This one is constant, and there are no others. There's one last thing, though, is that to put it in the way that's expected, is that the terms should be in order of decreasing degree, which is with a fancy way to say make the biggest ones come first. So is it that way now? No. No, because these ones in the middle need to be commuted. Whoops, I was just copying. Good. Any question about this one? Okay, it works just as well with subtractions. So something like, and for that matter, if there's more variables or something like that. So we could say something like, I don't know, 4x minus 5w, and then multiplied by, I don't know, 8w squared plus 9. So there's nothing special about x, and there's also nothing special about having just one variable. That's not sacred. Okay, so then now that's a subtraction, but at any rate, this factor here is still a binomial because there's two terms, and it's still FOIL. So as for that, the firsts are those. So can you do it in your head? What would it be? 32 w squared x. Which, some of you all might say, well, why not x times w squared? Would that be okay? Yeah? Because multiplication commutes. And you'll find that different opinions differ. So I went with this because that's what I heard someone say. And an argument for this would be like, well, isn't it true that w comes before x in the alphabet? Yeah, so maybe list them alphabetically. I don't know. In my head, because this x is on the left of the w on this side, I have various reasons for it to want to be on the left on this side too. But at any rate, it doesn't matter because multiplication commutes. So f, and then o would be what? 36x. The I term, okay, would be what?
Negative 40.
Right. So now we have to subtract. Because that's a negative 5, right? So that'd be 40, yes. And then what is the other bit? W cubed. Okay, good. And then as for the what is it? FOI, and then L?
45.
Okay. Right. So is it add or subtract?
Subtract.
Subtract. Okay, good. Any question about this one? So now we want to collect. Is there anything to collect?
No.
Okay, so this raises the question, what does it mean for things to be alike? Same degree, and moreover, same variables, right? Because this term that we're looking at here, that's 36x. So what's its degree in x? 1. What's its degree in w?
0.
And this one right here, its degree is 0 in the variable w, because it's the same as asking, well, how many w's do you see there? None, right? Whereas this one, this is degree 1, so they're both degree 1. But what? Variable's not the same, right? So in order to be alike, it has to have all the same variables, and all those same variables have to have the same degree. Otherwise, they're not alike. Good. Any question about this? FOIL. One thing. So we just did the product of binomials. So now we're going to do the square of a binomial. This one doesn't have a cute name that I'm aware of. So specifically, what we're doing is we're going to take a binomial, like a plus b, and we want to square it. So I'm going to say equal to, and then I'm going to write a formula here. I'm going to leave myself a blank to put a formula there. And now, what I'm going to do is I'm going to write the most common wrong answer. So if you're about to copy what I'm about to write, please carefully denote that it is wrong. So the most common wrong answer given when college algebra students, or even more advanced students, are given this is this. They say, well, it should be a squared plus b squared. That's the most common wrong answer. Now, it kind of makes kind of a certain amount of sense. It's wrong, but it makes a certain amount of sense because of the following. So what if we take that? What if we take that and I just modify it just a little bit? Let me back up just a little bit. You know how I write those dots there, and that y'all probably don't write those dots. You just leave it off. Okay. That's because when you write things side by side with no punctuation bit in the middle, that's understood to mean multiplication. All right. But when you mean add, you've got to write the plus. All right. So then, what's the punctuation that means exponent? Caret, right? So what I'm saying is that what that is that a plus b and then caret 2, like that. That's how you write it with punctuation. Caret. So what if I just take that caret, and by the way, that's not carrot like like Bugs Bunny, but it's spelled differently. but just how it's spelled, I'm not so sure. I just know it's not spelled like the vegetable. So suppose I change that punctuation to a dot, like that. What if we do that? Do we know how to do that? What's that called when you do that? That's distribution, right? So this would be a multiply 2 plus b multiply 2. And that would be a caret 2 plus b caret 2. So it's sort of like, it almost like makes kind of a perverse sense. If you could just like take this formula, which is correct, and then just replace all the dots with carets. It almost looks like it should work, but it doesn't. Okay, so let's make it. Let's figure out what it should be. So so I'll say that this one right here is actually correct. but with the operation is multiplication. So remember that when you write squared, or caret 2, that means that whatever it is I'm covering up, we need to make 2 copies of it and do what with them? You need to multiply them. Okay, so I'll do that. So a plus b, another a plus b, and then the thing we're supposed to do with those is multiply them. So you're telling me that we've got to carry out this. Here's a binomial and there's a binomial, and we want to compute their product. Man, it'd be really convenient if we had some kind of formula for the product of binomials. Foil. Okay, good. So then, if we write this down, the f term would be a times a, which is to say a squared. The o term would be what? AB. The I term? BA. And the L term? B squared. Now, concerning the terms in the middle there, this one, this term has 2 factors. Its factors are a and b, and this one has 2 factors. Its factors are b and a. And multiplication commutes, which means what? It means what about these 2? They're the same, right? It means they're the same thing. They have the same value. So that we could do this: a squared plus ab plus another ab plus b squared. So then altogether we could write this as something like a squared plus twice ab plus b squared. That's the formula. So a squared plus twice ab plus b squared. So in a sense, like I said, this thing right here between my fingers there, that's the most common wrong answer to this. And in a sense, you can even sort of measure how wrong it is by what's missing. What's missing from the wrong answer? The 2ab is missing. Okay, because you do have an a squared and you do have a b squared. Those really are there. But you also have the twice ab. All right. So by way of example, how about 4x, I guess, and then plus 5, and we'll square that. 4x plus 5, all squared. So it should be the first thing squared plus twice the product of the 2 things plus the last thing squared. All right, so now I'm going to make an error. So the first thing squared plus twice the first thing times the second thing plus the last thing squared. Okay, then I'll simplify this a little bit. So 4x squared plus, so that'd be 2 times 4 is 8 times 5 is 40. So 40x, and then plus 25. Nevertheless, there's an error on the page. Yeah, but I mean right there. What do you mean? Oh, the 4 2? Okay, right? Because it's this thing multiplied by itself, right? So it would be 4x, 4x, right? So there's got to be 2 of those 4s in there, and then you commute them together and they make a 16. So, did I just forget? Like, can I just fix this by writing 16 there? So let me offer a compromise and say, what if I just do this? Now would such a thing be graded correctly? Would you receive full credit? Right. So that's that. So I'll say it like this: is that that really is equal to that. Now this is correct currently. So that really is that. But if you were to submit this as a response to a question, you would not get full credit. Why not? So it's equivalent to asking, is that the same as that? Are those the same? But wait, I mean, I'm writing the square. I'm waiting for someone to say something. Y'all mean the right thing, but I'm fishing for a phrase that starts with O and ends with dir of operations. Yeah, that one, right? Right? So what this is saying, if you were to write it out with punctuation now, that would say 4 multiply x exponent 2. So now we have 3 items there. We have a 4 and an x and a 2. And we have 2 operations. We have a multiply and we have an exponent. And according to the order of operations, which of these occurs first? The exponent. As a result, in this statement, only the x is being squared. Not the 4. 4 is not being squared, as written. So, we need to say 4x multiplied by 4x, which means the 4x needs to be squared. Well, how do we edit this so that it will be the case that the 4x is squared? Y'all have said it. What is it? Parentheses. So you have to do this. So 4x in parentheses, then caret. Because now, again, there are still, in a sense, 3 items, 4x and 2 operations, multiply and caret. However, the parentheses are saying, no, we are going to do the multiplication first. Okay? So to make it right, like this. So I want to point out something, and that is like, I keep track of the minutes and over the course of the whole semester. I calculate it down as precise as I can. And I just spent like 5 minutes talking about those 2 red parentheses there. And it's not on a whim. It's because I've done this before. And I'll just I don't claim to have a crystal ball, but I'll predict that next week, some of y'all that are listening are going to leave off those parentheses and get points off. Okay? I hope not. I don't want that to happen, but statistics are what they are. Are there any questions about this before we move to the next thing? Okay. Good. Next thing. What if we do almost the same thing? So, but instead of a plus b, what if we make it instead of a plus b all squared? What if we make it a minus b, like that? Okay. Then how will it be different? Okay. So again, I'm going to leave myself a blank for a formula, but because it's so similar to the thing that we just did, now I'm going to do it like super fast. So this would be a minus b and then multiply a minus b again. So duplicate that thing and then multiply them together. So again, this is the product of binomials, but now we have these subtractions. F, that would be aa, which is to say a squared. What would the O term be? Minus ab. So I wrote a plus. So I'll write negative ab like that. And then what would the I term be? Minus BA. And the L term? Well, so we would have negative B multiplied by negative B. Right. So I'll be super difficult and write that. So can you see that the negatives will cancel? So that we'll have a squared, and then now I'll write minus ab. I'll commute those and write another minus ab. And then the negatives cancel, and we have plus b squared. So altogether, the formula is very similar to the previous one. In fact, we have an a squared, we have a b squared, we have a twice ab. All other things are present. However, what's the distinction? Right. This is still plus, so that's still plus like that. But now this one is a minus. So it's just like the other formula, except now the 2ab thingy is subtracted. Any question about that one? So it's just like using the other one. So I'm going to go to the next thing. So looking at those formulas, the first one we did was we're going to take an a plus b and another a plus b. And the second one that we did is we're going to take an a minus b and another a minus b. Now the formula we're going to do is we're going to take 1 and 1. We're going to take one of those and one of those. That's what we're going to do. But in order to be able to talk about that, you know, in a convenient way, we're going to define the word conjugate. So conjugate, you know, it's used in math like in its special math way, but generally speaking, like in the wide world, conjugate means two items are said to be conjugate if they fit together, and when they are together, something operates as you know, in the right way. So an example of two items that are conjugate are locks and keys. So the lock and the key are said to be conjugate to each other, and when joined, then the mechanism works. A different example would be something like in chemistry and biology. In chemistry, there's these things that make chemical reactions go faster. What are those called? In chemistry, they're called catalysts. But when you're in biology, you know, biology, they've got their own special words, and they are called enzymes. So a biological catalyst is called an enzyme. At any rate, all that it is, okay, which it's a little complicated, but you know, inside of each of us, you know, our cells and chemical reactions are occurring at a furious rate. And the reason why they're occurring is because all the necessary things to perform those chemical reactions are there. And in addition to that, there are these enormous protein molecules called enzymes, and the different pieces of the reaction fit into the enzyme, and then when they're fitted in, the enzyme squeezes together, you know, like, and you know, y'all come together, and then the chemical reaction proceeds. Okay, so when that happens, the enzyme and the reagents are said to be conjugated, fitting together and operating. Okay. Now in math, for reasons that aren't entirely clear, here's the following: is that the conjugate of a plus b is a minus b. And this is not really the place to explain exactly why that's the case, but I promise I'm not deceiving you. So the conjugate of a plus b is a minus b, and vice versa. So the formula that we're going to write down, it does have a name. Its name is the product of conjugates. Which is to say, a plus b multiplied by a minus b. All right, again, this formula is special because it's the product of two conjugates, but it's also generic in the sense that it's the product of two binomials. So we can, again, use FOIL. So this would be, again, I'm going to write myself a little blank there. And here we go. So writing down this formula. The f term would be a squared. What's the O term? Minus ab. What's the I term?
Plus ba.
And I agree with you, but I'm going to write plus ab. And
B squared.
which one?
Minus B squared.
Minus b squared. So now, again, we still have these things. We still have an a squared. We still have a b squared. Notice that a squared is still positive, but now b squared is negative. And concerning the ab's, notice that here we're saying that we've got a negative ab, and there we have a positive ab. As a result, in the formula, how many ABs will there be? None. So this is a squared minus b squared. So concerning these formulas, you know, the first one had an AB and another AB, and they were both positive, so it was 2AB. The second formula had an AB and another AB. They were both negative, so it's minus 2AB. This formula also had an AB and another AB, but one of them was positive, the other was negative, and as a result, there are not any left. So it looks like that. Any question? So we can have an example. Something like 4x minus 9 multiplied by 4x. So what is the conjugate of 4x minus 9? Thank you. So something like that. So would you please do it? Okay, so on the one hand, you could really just sort of like ignore this formula and just say this is the product of binomials. I'm just going to use FOIL. So you could just take that view, and that would be fine, and until we get to the next section, and then that'll make your life slightly more difficult. But at any rate, I'll say it is the product. Does it matter that here in the formula we wrote the +1 first and the -1 second, but here it's the opposite? No, it doesn't matter because multiplication commutes. Okay, so then this should be the first thing squared, and then minus the second thing squared. So I'm going to wait for someone to say it. Parentheses, right? The first thing, all squared. So you could write this as 16x squared minus 81. Any question about this? Yes?
So, like, on a wax exercise, would you want the answer to be 4x in parentheses squared minus 9 squared, or would you want it to be 16x squared minus 81?
Well, I'd want you to do it more or less like I have it written, to show an intermediate step.
Oh.
Because, you know, I mean, in the end, here, I mean, this is sort of a difficult, well, I don't want to say it's difficult. My experience of teaching this leads me to believe that students find it difficult to believe that it is your work that's being graded. So, like, if you just, like, don't write any work down, then there's nothing to grade and no points to give. So you should have no expectation of receiving any credit. Now, I can say that as many times as I want, but my experience tells me that what happens is that students turn in the first batch of assignments and get, like, lots of zeros. And then, you know, they complain and whine and gnash their teeth. And then I remind them, well, you know, that's why we have the redo policy on the exam. You know, if you didn't do good on that one, on the midterm, you can try it again. And usually it's by that time, you know, everybody's grade goes up by, you know, 15 points. Because no one wanted to believe me when I said, if you don't show your work, you will get no credit. Sorry. I just would love it if I could, you know, the semester's only 15 weeks long or whatever. I would love it if I could, like, reclaim those first 3 weeks from so many semesters of teaching this. Okay. Other questions? Yeah?
Since you squared that 9, is it a negative 9? So would it just be plus 89?
It's a good question. So concerning this, when you write that, let's consider. How about -3 squared, just to change the number a little bit. So what, if you evaluate this, what do you get? Do you get 9 or do you get -9? What do you get?
Get negative.
You get -9. This is -9. Now, I do not dispute that if you take a -3 and another -3 and multiply them together, you get a 9. I'm not claiming that. I'm saying that this is -9. Now, you know, we're still getting to know each other. You might not, you know, like, trust me on this. So maybe you trust TI. Now there I have it written, negative 3 squared. So what's it going to be? Okay, so now it's a legitimate question to ask, why should that be the case? But there's a reason. And believe it or not, the reason is exactly this reason. There's two facts. There's the order of operations. And there's also, when you write this, when you write that, that means something. That's actually a shortcut. Like someone's name could, their like full name could be like Patrick, and you might call him Pat. So this is like Pat. But the real name for this is negative 1 multiplied by a. That's its real name. So as a result, this is negative 1 multiplied by 3 caret 2. That's what that is. And now you have to ask, okay, there's 3 items, negative 1, 3, and 2, and 2 operations, multiply and caret. Which one comes first? Caret does. Does that answer it? Good. So that was my signal to myself that I've got to wrap it up. So I have one more thing to say before we do the quiz. So what we've been doing today is really just a glorified this. A multiplied by b plus c is equal to ab plus ac. Okay, now, going from the left-hand side to the right-hand side, doing this. What's the name for doing that? That's distribution. Now, concerning the right-hand side and ignoring the left-hand side for a moment, how many terms? 2 terms. And concerning each term, how many factors?
2.
And that one? 2. Do you observe that all terms on the right-hand side have a as one of the factors? So the factor a is said to be in common. So when you find a common factor, you can go from the right-hand side to the left. So we've been going left to right all day. And if you go right to left, what is this called? It's not distribution. What is this? What is it? Reduction would be good, but it's not. What is it? Factoring. Okay, so we're going to do one super quick example, and then we're done for the day. So 6x cubed y cubed plus 45x squared y squared plus 21xy squared. Now, concerning just the coefficients and just your knowledge of integers and things like that, do you observe that that 6 and 45 and 21 all have a factor of 3? So 3 is in common to all of those. As a result, we should be able to write that this is 3 multiplied by something or other, factoring out of 3. So I'm going to write that real quick. So 3 multiplied by, very good, 2x cubed y cubed plus 15 x squared y squared plus 7, yes, x y squared. Now, concerning just the coefficients, 2, 15, and 7 that are in there, do you observe that we can't get any more integers out? Okay. Now, this x cubed, that means xxx. And this x squared means xx, and that one means just x. So there are 3 terms in the parentheses. They all have some x's. They all need to give the same amount of x's, which means that whoever has the least, that's who limits the process. So how many x's can come out?
1.
Just 1. If we do that, that'd be 3x. And then what would I write here?
squared times y cubed.
Very good. X squared y cubed. And then
Plus
x.
16x
Y squared, yes, good. And then plus what?
plus 7y squared.
7y squared. Because that one gave up all of its y's. Of the three terms that are in there, do you observe that it is no longer the case that they all have an x? Finally, do you observe that they all have y's?
Yes.
How much y can come out?
2.
2 of them. So we would write 3x squared y squared. 2x squared y, because we took 2 away, plus 15x, because all of those went away, plus 7, because all of those went away. Do you observe that now, concerning those three terms, they no longer all have y's? As a result, this thing that we factored out is a common factor. These have all been common factors, but because nothing further can be taken out, this one has a special name. What is it? The greatest common factor. Good. So please put away your things. It's time for a quiz.